This problem is a standardized values or z-scores question, and we've got some information about 3 different plants and their mean, each of their respective means and standard deviations. So mu and sigma are shown there, the historical production volumes at these facilities, and then we're also given last month's production right here. Okay, and so we're going to standardize these scores using z-scores in this formula right over here. Now, just for a background or refresher on this, the standardized scores or z-scores are a way to establish or compare values from different populations. Okay, and we standardize them using these z-scores, and the z is in terms of standard deviations. So you're going to have results that are either negative, below the mean, or positive, above the mean. And when we standardize these, and normally this is, or typically this is drawn on a standard normal or a bell-shaped curve, and then when you standardize, 0 is the mean, and then you could have a -1 or a +1 would be 1 plus or minus 1 standard deviation, and then 2, and I'm running out of room, but you get the idea here. And this should bring to mind the empirical rule, right, where we said about 67% is between plus and minus 1 standard deviation, 95% between plus and minus 2 standard deviations, and then almost all data is going to be within 3 standard deviations. Okay, so that's just some background about the z-scores. Again, 0 is the standard mean, and then you get scores above and below the mean. You're standardized based on the data you have to work with. All right. And so that data, coming back to our problem at hand, is contained here. So we're asked in part A to compute z-scores for each of the plant's output for last month. Okay, so you take your x value, your sample minus mu, divide by sigma, and you get a z-score. Okay, and that'll say how many standard deviations this result was above or below the mean. All right, so in our first case here, so z of plant 1 is going to be our sample, 815 from this month, minus 750 over 225. Okay, z2 is going to be, what, 2500 minus 2355 over 375. And then, and this is the second plant, and I guess I need more room here, but I'll just put it down here for now, and then we'll do these calculations here in a minute. Z3 is going to be our sample, 1275 minus 1200 over 30. Okay, and so this is going to give us the standardized scores so we can compare the output among the 3 plants. Okay. Okay. So if we say 815 minus 750 over 225, that is going to be 0.2889 Z1. Z2 is going to be 2500 minus 2355 over 375. So that's going to be 0.3867. Okay, and again, these are just standard deviations. And all 3 of these, you'll notice, are above the mean. Okay, so this was the production. So this month, all 3 plants overperformed relative to their historic mean. And then the question is, well, we'll get to that question next, okay? So this is just under a third of a standard deviation. This is just under, or just over a third. And then this one is going to be 1275 minus 1200, so that'll be 75 over 30. So that's going to be 2.5. Again, 2.5 standard deviations above the mean for plant 3. Okay, so in one sentence, indicate which plant's performance was the least variable to support your response. Okay, so I'll just mention the reason I ask you to say something in one sentence is so that I don't get a book written about why it might be 1, 2, or 3. You should have a clear and concise answer, and I don't want to read a novel about it, just explain what it is. So in this case, right, this one, plant 1, is closest to 0. That is, it's closest to its historic output, so it is the least variable. So we would say plant 1's performance was least variable with a z-score of 0.2889 or plus 0.2889 standard deviations above its historic mean. Okay, so that's how we would say that. Now, looking back, if we were to convert this back and draw both our standardized, and this is for, I'll do this for plant 1 here. We've got 750, right? We've standardized that to 0, this mean. And then plus 1 standard deviation would be, what, 225, so 975 would be 1 standard deviation. And our result was, what, 815, I think, yeah, 815. And that standardized result was 0.2889. Okay, so it was above the mean, but not very far above the mean. So that's just a way of depicting that, or converting that back from our standardized values to where that value falls. So well within where you would expect. Now the plant, what was it, plant 3, 2.5 standard deviations above the mean. Again, going back to the empirical rule, that would be far, far above the mean production. And so that would probably warrant looking a closer look about what happened there, about why that plant had such a big change in its output relative to its history, as well as relative to the other plants.